eyes up.
You're on here to.
Okay, now let me get in here. Okay, back to part 2 because I ran out of time. And I have got lovely visitors, Andrew Coy and little Logan Antoine. Just thought they would say hello to everyone, as I continue my wonderful lesson. Let's go find the cosine of 240 degrees. So what I'm going to do, okay, clearly my light pen is kind of going crazy for a second. So what I'm going to do is I'm going to draw a 240 degree angle, which is somewhere over here in quadrant 3, because this is 180 and this is 270. So from here to here was 240 degrees. So now what I need to do is find the reference angle. And the reference angle, once again, is always between the x-axis and the terminal side of your angle. And here he is, he's theta prime. This is the reference angle. But I actually need a value for him. So if I crossed 180 and I went further to 240, then the reference angle will be 240 minus 180, which is 60. So this is actually a little 60-degree angle right there, okay? So your reference angle is 60 degrees. If you do this thing called drop a perpendicular, it creates a right angle for you. So you have created a little reference angle with a cute little reference triangle, and it just so happens to be a 30, 60, 90-degree triangle, which again, you know the lengths for that. It is going to be 1, 2, and the square root of 3, okay? And again, this is accurate. However, because we're on a coordinate plane, if you move to the left of 0, these numbers are negative. If you move down, that is negative. And I know, technically speaking, there's no such thing as a negative length, but this is kind of where we're at. So when I want to know the cosine, and if it helps you to write down SOHCAHTOA, cosine is adjacent over hypotenuse. And you use your reference angle as the angle by which you are using adjacent and hypotenuse. So your answer is -1/2. Okay, so this is how you are evaluating an angle without a calculator. You draw the angle, you find the reference angle, you drop a perpendicular, which is going to create for you a cute little reference triangle. You know the lengths to it. Cosine is adjacent over hypotenuse, adjacent over hypotenuse. Okay, let's do one more. Let's do the tangent of, let's go 300 degrees, okay? So if I draw a 300-degree angle, I wind up over here in the 4th quadrant somewhere. Okay, so from here to here is 300 degrees. Remember, this is 270, and a full circle is 360, okay? So I've just found a 300-degree angle, and now I need this angle right here. I need the reference angle, and it's always between the x-axis and the terminal side of your angle. And so what you're kind of looking at is you're about 60 degrees shy of being a full circle. If from here to here is 300 and the full circle is 360, then your reference angle is going to be 360 minus 300, which is 60. So your reference angle in this problem is 60 degrees, okay? And he's going to use us, he's going to help us answer this question. I'm going to drop a perpendicular, make a reference triangle, and that's going to create for me a 30, 60, 90 degree triangle. So again, it's 1, hypotenuse 2, square root of 3. And in an angle in the fourth quadrant, numbers that go to the right of 0 are positive. Numbers that go down are going to be negative, okay? And the hypotenuse will always be a positive. So in order to do tangent, it is opposite over adjacent. So that will be negative square root of 3 over 1, which is really just negative square root of 3. So here's another example of how to evaluate a trig function by using a reference angle, dropping a perpendicular, making a reference triangle, and taking the information at hand, okay? So that's kind of how we work on doing that. There's going to be another problem that you have in your homework, and it's basically really, I'm going to do problem number 5 in your homework. And the directions say you are given a point on the terminal side of an angle. Find the sine, cosine, and tangent of an angle. And here's what this means. If I were to draw the point negative 4, 4, I'm going to be this dot right here, negative 4, 4. Here is the terminal side of my angle that goes through this point. So what I'm really talking about is an angle like all the way over here. But the reason that they give you this point is so you can basically know the sides of your triangle. And here's what I mean by that. This is your reference angle. You're going to drop a perpendicular, but you're going to know this guy has a length of negative 4. And why did I say negative 4? Because I went left. This length has a length of negative 4. And how did I know that? Because I went down, okay? So if you want to know what your hypotenuse is, it's Pythagorean's theorem, okay? So a squared plus b squared equals c squared. So that's 16 plus 16 equals c squared. 16 and 16 is 32. So you take the square root of that. So that turns out to be 4 on the square root of 2. So this guy right here is 4 on the square root of 2 as the length. So the directions wanted you to find the sine, cosine, and tangent of the angle. This one's a little bit different problem. It doesn't actually give you the angle measure itself. So it wants the sine of the angle, the cosine of the angle, and the tangent of the angle. So in this setup, the sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. So although I've taught y'all to never leave a radical in the denominator, I am, just for sake of simplicity right now. In the words of Andrew Coy, he told me, Coach Golden, you just need to keep this simple. So that is kind of what I'm going to do right now. Some of your problems on your homework may be given to you in a radian measure. And if that's the case, the first thing I would do would be to convert it to a degree. So your homework for tonight